Hello, hello. Let's solve some examples where we multiply by decimal. We are on page 45 of our textbooks, and I want to bring to your attention that in examples A, B, C, D, E, F, we are multiplying by 1/10. We are multiplying by 1/10. Okay, and in the further examples G, H, I, J, K, L, I hope you see that we're multiplying by 100s. By 100s. We learned in the previous video that to multiply by 0.1 is the same as to multiply by 1/10, which is essentially the same as to divide into 10 equal parts, right? So what happens? We are going to reduce the numbers, the factors given in A, B, C, D, E, F 10 times. 0.6 become 6/10 becomes 600s. 600s will reduce to 6,000s, and 5 ones will reduce to 5/10. Notice the shift of the decimal point, but I do want you to understand the logic behind it. Let's look at examples D, E, F. I hope you're getting a hang of it. From 23 ones, when we multiply by 1/10, right? Essentially dividing 10 times, we get 2.3, right? We reduce the number 10 times. 3 and 4/10 becomes 34 hundredths, and 14 hundredths will reduce to 14 thousandths. Now let's take a look at another set of examples when we are actually multiplying times 100. To multiply by 0.01, 100, it's the same as to multiply by 1 over 100, which is essentially we're reducing the number 100 times. We're going to get a smaller number. Yes, we are multiplying, but because it is a fraction that we are multiplying by, the number will become smaller, unlike what maybe some elementary school teachers told you in the past. Not always we result in a bigger number. So let's go. 4 ones times 100, or 100ths of 4 ones, is 0.04. 4/10 reduces to 4,000s. 8 ones becomes 800s. 42 ones divided by 100 becomes 0.42. 83.4 becomes 834 thousandths, and 6.2 reduced 100 times becomes 0.062, or 62 thousandths. Let's take a look. Our decimal point traveled 2 places. Our decimal point moved 2 places to the left. The decimal point moved 2 places to the left, reducing the number 100 times. Let's take a look at more interesting examples when we're multiplying on page 46. So example number 5. Example number 5 I really like because I'm going to show you an easy way to look at all of these cases. So let's first look at number 5. Use 34 times 6 to solve a decimal problem that is 3.4 times 0.600. So step 1, everyone. Step 1, we're going to solve 2 examples. We're going to solve A, we're going to solve B, and we're going to solve number 6 in the same method. Sometimes it's not very easy to do mental math, although in this particular case, I know you can do mental math. So let's use stacked algorithm. Okay, so we're going to write 3.4 times 0.06. In other words, 3 and 4/10 times 600. Step 1, ignore the decimal points in your stacked multiplication and multiply as if you're multiplying 34 times 6. Again, the first step of stacked multiplication when we're dealing with 2 decimal factors, first multiply the digits. And of course, the digits will be 2, 0, 4. However, we're not done. We need to place the decimal point correctly. And where would that be? So here is how I teach my students. Take a look at the first factor. 3.4 has 1 decimal place. 600 has 2 decimal places. Your final product will have the sum of all decimal places, which here results in 3 decimal places total. So we go 1, 2, 3. The answer is 0.204, or 204 thousandths. Let's take a look at example B. 95 hundredths times 0.4, or 4/10. So 0.95 times 0.4. We multiply as per usual. We do not pay attention to decimal places as if we're multiplying 95 times 4, which you've done since third grade. And the digits are 380. But of course, the answer is not 380, right? 0.95 is about 1 and 0.4 is about half. So we're going to get a much smaller product. Now let's take a look at what's happening with the decimal places. The first factor has 2 decimal places. The second factor has 1 decimal place. Let's underline it. Therefore, the total number of decimal places in your product will be 3. We add 2 plus 1. So we have 1, 2, 3. And the answer is 380 thousandths. And finally, the third example, number 6, multiply 2.35 by 8 tenths. Step 1, we're going to multiply as per usual, stacking algorithm, right? Just to get our digits right. And we have, it's as if we're multiplying 235 times 8, but then we're going to compute the total decimal places. We have 2 decimal places in the top factor. We have 1 more decimal place in the bottom factor. And therefore, our answer will be, I'm just going to write down the digits, 1, 2, 3. We count 3 decimal places, and the answer is 1.880 thousandths, which is of course the same as 1.88. It's equivalent. I hope you understand that we can use stacked multiplication method to multiply crazier decimals. Step 1, again, compute as if you don't notice the decimal places. Ignore them. Step 2, add up all the decimal places in your both factors, or maybe you have 3 factors, and that many decimal places will go into your final